Impurities in drug substances. To understand impurities, we must first get to know what chemical purity is. Chemical purity is a pure compound, contains a single chemical and is not polluted with any other chemical or elements, mean it is not contaminated. Why do we want to use pure chemicals? It is to ensure the safety of our patients and also to make sure that our product does not become toxic or flammable. In order to test the purity, we can use this purity test that is listed in the pharmacopoeia. All these tests can be used to calculate the amount of impurities present in our product or even in our chemical reagents. When impurities are detected, we can set the limits in order to control them. This lecture will be divided into two. First, we will talk about the impurities, and then we will talk about what is limits. This is the learning objectives for this lecture. Impurity is any component in a drug substance that is not the chemical species defined as the drug substances. Meaning, if it's unwanted in our drug substance, it is considered as impurity. Impurity does not only mean dirty things, it's just unwanted drug substances. Nature of impurity can be either inorganic or organic. The substances that we use should almost be pure, but however there are varying degrees of purity. So we need to control the impurity levels to ensure safety and quality of drug products. Impurities can have these effects. It can be toxic, or traces of it can accumulate and become toxic. Harmless impurities, they can be harmless, but when it is in large proportion, it might reduce the strength of the drug. It can also change the physical and chemical properties of the drug. It can cause technical difficulties. It can cause incompatibilities with other substances, lower the shelf life of the drug, and also change the color or the taste of the drug. Impurities can be classified into 5 classes: foreign substances, toxic impurities, concomitant components, signal impurities, and ordinary impurities. Foreign substances are materials introduced by contamination or adulteration. Contamination, for example, to do the reaction, you use not clean glassware that can introduce foreign substances. Toxic impurities is when the impurities can cause toxic effect, means undesirable biological activities. It can arise out of synthesis or during the preparation of the drug, and also degradation. Concomitant components are usually the chemical compounds that are related to the geometrical or optical isomers. For example, in the solvent or the chemical, you just want an R configuration. So if there is an S configuration, the S configuration will be considered as impurity. In this case, as a concomitant component. Signal impurities are impurities that can be process related, or for example a byproduct from the reaction, and it can cause other reaction to happen in the process. Compared to ordinary impurities, it can also be a byproduct from a reaction, but the byproduct will just be an observer of the reaction. It will not react with other reactants. There are 8 sources of impurities. The first source is impure starting materials. This is an example of an impure starting material where we want to synthesize miconazole. We will first synthesize the top part of miconazole in this pathway. So this is the first part of my conazole, and now we will add a dichlorobenzyl bromide to the structure to get the structure of my conazole. My conazole with 2 and 4 dichlorobenzyl. So this can be an impure material. For example, in these cases, this is the conazole structure that we want, and we can have impure starting materials which will give us a wrong product. So this is an impurity in our process. Second is incorrect product of a particular stage, not the final product, but within the pathway. It gives us a different product. So the reaction sequence will be incorrect. So to overcome this, we usually would recommend intermediate product purity test during the process. Or other reactive functional groups can also be blocked or protected. And again, we recommend for assessment of chemistry or chemical purity to be tested in each reaction step. This is also an example of an incorrect product of a particular stage in the synthetic process, where in this reaction, your desired product can be yield, but also a second product which we don't want. This can also be considered as an impurity. This is the second example. This is our desired product. We can also have a byproduct or a second product, and this is considered as an impurity. Third is reaction residue. The reaction residues, for example, the catalyst, the reagent metals, any mineral or heavy metal residues from reaction processes, and also inorganic ions from salt separations. So they can be a residue from the reaction, and it can be either carried over or it is an impurity in the process. This just shows you the limit set for these residues, but we will come back to this later. Fourth sources is solvent residues where reaction is incomplete. So you still have your reagent carried over, and this reagent can further react with other reactants and make other products, which will again cause impurities. Fifth is precursor carryover, where you can have two possibilities. One, a catalyst will be carried over into another synthetic step, or a solvent residue will be absorbed onto a crystallized product where it dissolves and then it can continue on into another reaction. 6 is non-stereospecific reactions, where the product of this reaction is not stereospecific. You can have an R configuration and you can have an S configuration. So in some drugs, for example, now new drugs, they are developed as single isomers, for example, in R configuration. So if the reaction is not stereospecific, the S configuration will be considered as an impurity. This is an example. 7. Polymorphic forms. When you crystallize the products, it must have the correct crystal forms, because these crystal shapes can affect the solubility, hardness, color, melting point, chemical reactivity, and also composition of the drug. So these are the different crystal shapes with 7 classes: cubic, tetragonal, orthorhombic, monoclinic, triclinic, hexagonal, and trigonal. And the last source of impurities are breakdown of products. This is when stability of the drug fails, so there is degradation of products or breakdown of products. So these are some examples. So when you know there are impurities, we need to control the impurities. Why do we allow impurities? Why is it permissible? It's because it is impossible to avoid impurities. Impurities can also be related to errors. So it's impossible to avoid impurities. That's why we allow, or it's permissible, impurities. But it must be in a certain limit. Why we allow, for example, for harmful impurities, we allow, but it is in a very low permissible limit. Means the amount must be really low. For harmless impurities, there are different factors to consider when you want to set the limit. But also we need to consider if it is very costly to obtain a highly pure substance. This high or low limit we will be discussing in class. So impurities that are present in excess of 0.1 should be really low. Second is route of administration. Oral and topical would have different limits. For oral, because it goes into the system, so the amount of impurity should be lower. But topical, because it's an external use, so the amount of impurities could be higher. The daily dose, frequency and amount. If the drug is taken frequently, therefore the amount of impurities should be lower. For example, the target population, if for pediatrics and also for old age patient, the impurities should be lower. Pharmacology of the impurity. If the pharmacology of the impurity can cause other pharmacological effects, therefore this type of impurities should be really low. The source of the drug substances. For synthetic, the amount of impurities allowed should be lower compared to natural. The duration of the therapy. If the duration of the therapy is longer, the amount of impurity should be lower. And also the ability of the manufacturer to produce high quality drugs. These are the factors that you should consider in setting the limits. This is the drug development stage where they would consider to have an impurity profile. Impurity profile will be discussed again in class, but this is just the lecture slide that you can have a read. Pause in every slide. This is the reason why you need an impurity profile. 3 reasons why. And this is what you can use to characterize impurities. Revising the learning objectives for today. Okay. See you in class. Thank you.